the part B, second half. So percent. Percent literally means per 100. As a decimal, we're going to have point, and we have tenths place, hundredths place. Since this is percent, 16% is 16 hundredths. If you say that out loud, you know 16 hundredths is 0.16. As a fraction, we have 16 over 100, but we know we can reduce that right away. They're both even numbers, so you have to be able to reduce it. So we can find the greatest common factor. We can kind of work backwards. We know that 4 goes into 100 evenly, and if you divide 100 by 4, you get 25. If you divide 16 by 4, you get 4. So 4 over 25, and that's actually as low as you can go with that one. If we wanted to, we could have made a tree, a factor tree, and gone from there. We have done that before, but this works. As a fraction, we have 1/20th, and so again we're going to find the percent here, and that'll tell us the decimal also, because percent means per 100. So 1 out of a 20, so I'm going to put 1 over 20, and then I have to turn the 20 into 100. So 20 times what equals 100? Okay, if we're not sure, 2 times 5 is 10. We just have an extra 0. So 2 times 5 equals 20 times 5 equals 100. If we do it to the top or to the bottom, top gets jealous, says it's not fair. 5 over 5 is the same as 1, right? It's the same as 1. So I'm not changing the number, I'm just changing the way that it looks. I'm really multiplying 1/20ths by 1. So 1 times 5 then is 5. So my answer should be 5 over 100. And 5 over 100 is 5%. This is per 100. So my answer is going to be 5. And then that is 5% again, or 5 hundredths. So I have my tenths place after the decimal, and then my hundredths place. So I'm going to have 0.05 for my decimal. Hopefully that's what we got. Moving along. Refer to the figure below for problems 11 and 12. Dimensions are all angles, and right angles. Good to know. Alright, so we're going to section this off first because it's the easiest way to do it. If this is 3 and this is 2, and this is a straight line, that means this little box, I'm going to make 2 rectangles. This little box is 1, so I have a 1 by 1, which is 1, area is length times width. And then I have a 2 by 3.5, so again length times width, 3.5 by 2. You're going to break that down and say 2 times a half. If I have 2 halves, I have a whole, right? So 2 times a half is 1, and then if I take the whole numbers, multiply those together, 2 times 3, you know what, I'm finding the area, and I'm doing number 12. That's why you read the problem first. Learn from this, okay? 2 times 3 is 6, and then the 2 times a half is 1. So 6 plus 1 is 7. So the measure of the area for this rectangle is 7, and that one is 1. So the area, skipped ahead, is 8, and that's going to be inches. It tells me right up here that it's in inches. And since it's area, it's going to be squared. Now, back to problem 11. Sorry about that. We know this is 1. We'll cross this out. We don't need to know that's 1. We only need to know that's 1 because this other side then is also 1. So we have 3 here, 1, 1. And this is 3.5 all the way from here to here. If we draw a little line straight up, we can take 1 off, which means this is going to be 2.5. And then we have everything labeled. Then all we have to do is go through and add them all up. So we have 3 plus 1 is 4, plus 1 is 5, plus 2.5 is 6.5, 8.5. We missed something. 3 4, 5, I missed this one, 3, 4, 5, 6, 7.5, 8, 9.5, 9.5, just add this half there and make it an even 10, and then 3, our perimeter is 13 inches. Hopefully you followed that. I missed one of the inches in there, missed this side inch right there. But the big thing for these is knowing how to split it up. So I'm going to split up my rectangles and then use the given numbers to find the numbers that are missing. On to 13. We need to find what n equals. So what do we do to 27 to 18 to make it 27? And the easiest way to do this is find a number that goes into both. Looking at it, the greatest common factor that goes into them is 9, right? So I have 9 goes into 18 twice, 9 goes into 27 3 times. So if I were to do a factor box and I wanted to reduce this, I could really say 18 to 27 is the same as 2 to 3. And then 10 is the same as what? So I have 10 over 2, and that's going to equal, if 10 is 2, we divide it out and get 5, multiplied by 3, and we'd get 15. That was not explained very well. Let me try this again. Let's see. Get rid of that. Let's reduce this first before we do anything else. We have 10 and we have 18. Let's reduce that. They're both even numbers, so we have 5 over 9. Now it's easy. Usually with the Saxon math, you're going to be able to reduce before you do anything else. Sometimes I look at it and I see it and I see the answer, and so it's kind of hard to work backwards. But let's reduce first. Divide them both by 2, 5 over 9. Then it gets easy because 9 times what is 27? Well, we know our math facts. 9 times 3 is 27. If we do it to the top number, we have to be fair and do it to the top number, otherwise it gets crabby, right? So 9 times 3 is 27, 5 times 3 is 15. So my answer is 15 equals n, or n equals 15. I'm going to circle that answer because that's ugliness and it's kind of hard to find. Almost done. Wow, maybe not. 6 equals 4 plus 1 plus, or 4.1 plus p. So really what I'm doing is I'm just working backwards here. 6 minus 4.1 then is going to equal p. So if you just subtract it out, work through the math, pause it, work through it, you should get an answer of 1.9. Next problem is a, please excuse my dear Aunt Sally problem, right? So no exponents or parentheses, so we're going to first do multiply and divide left to right. 5 times 5 is 25. We do that first. We're not going to subtract the 5, even though it's tempting because it's subtracting. We have division first. 5 divided by 5 is 1. So we have 5 plus 25 minus 1. Now the order doesn't matter, so we go left to right. 5 plus 25 is 30, minus 1. Answer should be 29. Next one, again, please excuse my dear Aunt Sally. Please, parentheses. Do you see any? No. Excuse, exponents. 2 to the fourths. 2 times 2, that's really ugly, times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 2 times 8 is 16. So we have 16 plus 3 to the 0. Anything to the 0 power is always 1. 169, the square root. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. If you don't know that, it's okay. I would have guessed and tested if I didn't know and just say, okay, what's 12 times 12? 12 times 12 is 144. Okay, it's a little more than that. And just worked it out until you find out what it equals. And then we also had 10 to the third here. So 10 to the third is 10 to the first is 10, right? 10 to the second, we're going to add another 0. 10 to the third, we're going to add one more 0. So we have 1,000 minus 13 plus 16 plus a really ugly 1. That is a 1, not a 2. Fat 1. So let's do the easy part first. 16, we should go left to right, but just because it's not going to make any difference. 16 plus 1 is 17, and then subtract 13 from that and you have 4. Maybe that was more confusing than it should have been. Let's go left to right. 1,000 minus 13 is 987. Now we add 16 to that. Well, if we just took away 13, and now we're adding 16, the difference between these two is 3. So my answer should be 1,003. Add one more for my plus 1. All this big jumbled mess equals 1,004. And math can be messy sometimes, and that's why you always circle your answer. All right, hopefully 100% so far. So these brackets mean absolute value or distance from 0. Regardless of which way you go from 0, if you go plus 8 or minus 8, you are still 8 away. Absolute value of negative 8 is 8. 3 more problems. Gonna make it. Okay, 5 4/9 plus 3 1/2 minus 1 2/3. So we need to get all of these denominators to be the same. So 9, 2, and 3, what's a number that they all go into? Easy way to do this, the answer is 18. Easy way to do this is to, it's the longest way, go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc. 3, 6, 9, 12, 15, 18, 21. And just to list out all of the multiples, 9, 18, 27. Well, if you would have done that, you would have seen that 18, all of them go into 18. So what do I do to 9 to make it 18? I multiply it by 2. I have to do the same thing to the top. So if I multiply the top by 2 also, I have 8 over 18. I'm just going to do the fractions first because that's easy. We'll leave that. Okay. 2, what do I do to make 18? I multiply it by 9. So we have 9 over 18, which is the same as a half. And then we have 2/3. 3, we multiply it by 6 to get it to be 18. 6 times 2 is 12. Now we can just go right through, work through our problem. We have to do the parentheses first. We're going to have to borrow. You can't take 12 away from 9. So we're going to cross out our 3. We're going to make our 3 2, and we're going to give an extra 18 to this because we're giving it a whole 1. 18 over 18 equals 1, right? So we give that whole 18 to the 9, and now we have 27. So 2 27ths, scribble out that 9, 2 27ths, 2 and 27 over 18. 27 minus 12 is going to be 15 over 18. 15 over 18. If you didn't follow that, I couldn't take 12 away from 9 because I only have 9 to give. So I had to cross out my 3 and make it a 2. So then I took a whole, which is 18 over 18, and added that to 9 over 18. 18 over 18 plus 9 over 18 equals 27 over 18. 27 minus 12 is 15 over 18. 2 minus 1 is 1. So I'm going to move on down to here because I'm out of space. But I have 5 and 8 over 18 plus 15 over 18. Okay, 15 plus 8 is 23 over 18. So I have 5 and I did something wrong. I forgot to put my 1 up here. 2 minus 1 is 1, so we needed a 1 up there. We need a 1 up there also. Okay, so we have 18 plus 5 is, I'll just keep working down here, 23 over 18. And 5 plus 1 is 6. Now, this is an improper fraction. They're not going to like that, so we're going to rename it. We're going to take one whole out of this, so 18 over 18. Okay, we have 6 and 23 over 18. 6 and 23 over 18. So I'm going to take away a whole, just from the fraction part, because I have more than a whole. 18 over 18 is 1. So I'm taking away 1 from that fraction part, and I'm sticking it over here just because I'm renaming it. So instead of 6, I'm going to have 7 because I took 18 away from there. 18 over 18 away. I took away 1. So 23 minus 18 is 5 over 18. 7 and 5 over 18. 2 more. Inside the parentheses first, we know to divide it, we actually are going to invert and multiply, right? So let's make this into an improper fraction, the entire thing, then we're going to invert. So we take 5 times 2 is 10, plus 2 is 12. So we have 12 over 5. But we have to invert it. So 12 over 5 inverted is 5 over 12. Since we're dividing by fractions, we're really inverting and multiply. So we have 4 over 1 times 5 over 12. 4 times 5 is 20. 1 times 12 is 12. We have 20 over 12 so far. And now we're done with the parentheses. Goodbye. So then we take 3 and 3/4 divided by this. Well, luckily we already have this as a fraction, so instead of dividing by this, we're going to multiply by its inverse, times 12 over 20. Again, it's going to be easier if we can just multiply straight across, so let's make this an improper fraction also. 4 times 3 is 12, plus 3 is 15. We keep the same denominator, 15 over 4. And that makes sense because inside of this you have 4 3 times, which is 12, and then 3 left over. 12 plus 3 is 15. So 15 over 4 times 12 over 20. And just like Saxon does, we can reduce this before we start multiplying giganto numbers. Let's reduce it. 15 and 20. 5 goes into both of them, right? So let's make it 3, and let's make it 4. 12 and 4. 4 goes into it. 4 goes into 4 once. 4 goes into 12 3 times. If you can look through all this mess, we have 3 times 3 and 1 times 4. 3 times 3 is 9. 1 times 4 is 4. We have 9/4, but they don't usually like our answer in improper form. Because if you go to order a pizza and you say, I want 9/4 of a pizza, they say, what are you talking about? No, I want 2 pieces of pizza, 2 pizzas plus a 4th left over. I find that out by saying 9 goes into 4 2 times, and I can divide it out like that. Or I could just say 4 goes into 9 twice. 4 times 2 is 8, right? So I have 2 holes, and if I say 4 times 2 is 8, 9 minus that 8 is 1, and so my answer is going to be 2 and 1/4. Circle my answer because I got a big sloppy mess. Last one, almost there. Okay. Work with, so let's just move them all over. We'll move this over 1, 2, 3 spots, and we'll remember that and we'll come back to it. We'll make it 5. And then this is 1, 2 spots. We'll move it over 2 spots. We have 5 times 5. That's a pretty easy problem. We can do that, right? 5 times 5, 25. Wonderful. 5 times 5 times 2.2. Oh, 25 times 2.2. My answer should be about 50 because I know that 25 times 2 is 50. This is pretty close to that, so we're done with this up here. Goodbye. 25 times 2.2. 25 times 2 is 50, so I'm going to put my 0 in there if it'll let me, carry my 5. And 25 times 2 is 50, plus I had that 5 left over, so my answer should be 55, right? So I have 55, but back at the very beginning I decided I wanted to make this problem easy. So I moved the decimal over 5 places. And since I didn't make it 5 thousandths, I made it 5. Which is bigger, 5 or 5 thousandths? 5, right? So I made the number way bigger, so the number should actually be way smaller. I actually need to move it over. I moved it over 5 decimal places, so I'm going to need to move it over 1, 2, 3, 4, 5 spaces. So put in my 0, 0, 0, decimal 0. So basically what I did there was I moved the decimal at the very beginning, and then I multiplied. And then I remembered how many spaces I moved it at the beginning and moved it back at the end. So I have this big nasty 0.00055 as my answer. That is the pretest. Hopefully that makes sense to you.